Hello students, today's topic of the day is degree of dissociation. Degree of dissociation is generally used when we are discussing about the chemical reactions in chemical equilibrium chapter and in ionic equilibrium chapter. This degree of dissociation is generally used or mostly used for reversible reactions. In general, if I want to say about degree of dissociation, so it is the amount or moles of a substance dissociated out of total moles of the substance. This is generally represented by alpha. This is represented by alpha, and mathematically I can write alpha is moles dissociated upon initial moles taken. This we can also write in terms of concentration dissociated upon the initial concentration taken. Let's try to understand it with the help of an example. Let us suppose we have a reaction like NH3 dissociating to give half of N2 plus 3 by 2 of H2. Let us assume that at T is equal to 0, means when the reaction is starting, we have 10 moles of NH3. And let's say at equilibrium, 4 moles of NH3 is dissociated. So in this case, if I want to define degree of dissociation, that will be equal to 4 divided by 10, which is 0.4. If I want to define the percentage degree of dissociation, so that will be alpha into 100, which is 40% in this case. So this is first. Let us say second example. This is example 1. Let's take second example. In this same reaction, we're having NH3 is dissociating to give half N2 plus 3 by 2 H2. T is equal to 0. Let's say 10 moles is given. And T is equal to T equilibrium. Let's say 4 moles of NH3 is present at equilibrium. So if 10 moles we have taken initially and 4 mole is left, this means that 6 moles of NH3 is dissociated. 6 moles of NH3 is dissociated. So alpha, if I want to define, that will be 6 divided by initial mole, which is 10, which is 0.6. So percentage degree of dissociation will be 0.6 into 100, which is 60%. Let's take one more example. Example 3. Same reaction, NH3 gives half of N2 plus 3 by 2 H2. Now in this case, initially 10 moles of NH3 is taken, and now they are saying alpha is 0.2 or percentage degree of dissociation is 20%. So at equilibrium, how many moles of NH3 is present, how many moles of N2 is present, and how many moles of H2 is present, that we have to find. Now we can see that initially 10 moles is taken and alpha is 0.2. So we can write alpha is moles dissociated upon moles initially taken. So alpha is 0.2, that is equal to moles dissociated divided by initial mole is 10, which means moles dissociated, that is 0.2 into 10, which is 2. It means out of 10, 2 mole is dissociated. So moles left will be how much? 8 moles will be left. Now 1 mole of NH3 will give half mole of N2. So 2 moles of NH3 which is dissociated will give 1 mole of N2. And 1 mole of NH3 gives 3 by 2 moles of H2. So 2 moles which has dissociated will give 3 moles of H2 gas. So like this we can find the moles of all the components. They can ask you the total number of moles at equilibrium. So total number of moles at equilibrium will be 8 plus 1 plus 3, which is 12 moles. They can also ask you the mole fraction of each component. So we can write mole fraction of NH3 is equal to 8 upon 12. Mole fraction will be moles of that particular component upon total number of moles. We can also define mole fraction of N2, that will be 1 by 12. We can also define mole fraction of H2, that is equal to 3 by 12. Now let's say if total pressure at equilibrium is 24 atm. Let's say that total pressure at equilibrium is equal to 24 atm. Then what will be partial pressure of NH3? So if we apply Dalton's law of partial pressure, we can write partial pressure of NH3 is mole fraction of NH3 into total pressure. So that will be equal to 8 by 12 into 24, which is 16 atm. Same way we can write partial pressure of N2, which will be equal to mole fraction of N2 into total pressure, which is equal to 1 by 12 into 24, which is equal to 2 atm. And we can say in same way we can write partial pressure of H2, which will be equal to mole fraction of H2 into total pressure. So it will be equal to 3 by 12 into 24. So that will be equal to 6 atm. So like this we can find the partial pressure of each component in the system. And if partial pressure is known, we can also calculate the value of Kp, that is equilibrium constant in terms of pressure. So expression for Kp, if you want to write, that will be equal to partial pressure of N2 into partial pressure of N2 to the power 1 by 2 into partial pressure of H2 to the power 3 by 2 upon partial pressure of NH3. Now after substituting, you'll get the expression of Kp. Let's take few more questions based on degree of dissociation only. So let's take a reaction, like let's take the same reaction. NH3 is dissociating partially to give you, this time let's take 2NH3, dissociating to give N2 plus 3H2. And let's say at T is equal to 0, concentration is C. And degree of dissociation is alpha. Degree of dissociation is alpha. So at equilibrium, what will be concentration of NH3? So we can see that alpha is equal to moles dissociated or concentration dissociated upon concentration initially taken. So I can write alpha is equal to X upon C. So X, which is moles dissociated or concentration dissociated, will be C alpha. So at equilibrium, what will be the concentration left? So it will be C minus C alpha. A very common mistake is that generally a student writes it as C minus 2C alpha, because they see that coefficient of NH3 is 2, but that will be incorrect. Concentration dissociated will be C alpha. So concentration of NH3 at equilibrium will be C minus C alpha. Now when we have to find the amount of N2 and H2, then over there this coefficient will be used. Like we can see that 2 moles of NH3 will give 1 mole of H2. So if C alpha moles of NH3 is dissociating, how many moles of N2 should be formed? So that should be C alpha by 2. And same way 2 moles of NH3 gives 3 moles of H2. So C alpha moles of NH3, which is dissociating, will give 3 C alpha by 2. So these will be the concentration of species at equilibrium. So like this we have discussed about this topic, that is degree of dissociation. I hope this topic is clear to all of you. If you have any doubt, you can ask me in the comment section. And if you like the lecture, please subscribe to the channel. Thank you so much.